Hi, welcome to MiceTech Talk with the technical information scientists at the Jackson Laboratory. My name is Dr. Dolores, and I'm coming to you from my house on the west coast of the United States. Today, I'm very happy that we have a guest. It's my colleague, Ralph Garros, Director of Business Development at JAX.
Very good. Perfect pronunciation of my last name, Dolores. So
Great.
unlike Dolores, I'm not based on the US West Coast, but in Germany. And I'm not going to have my coffee, but I'm actually more waiting for my evening beer, but that has to wait until after the talk.
Excellent. Our job as technical information scientists is to serve the research community by answering all mouse-related questions. You may recognize us from our webinars that we typically do on Thursdays, and or you may have called us or emailed us for questions. So MiceTech Talk is a weekly 15-minute podcast-style webinar where we answer frequently asked mouse questions. So hopefully you've got your coffee or you're waiting for dinner if you're Ralph, and you can put your feet up because it's time for MiceTech Talk. So today we're going to talk about Humanized Mice Part 1. We have prepared a few discussion topics, and you can ask questions using the chat that is available to you, and we'll do our best to answer them.
Cool. I mean, I guess I can start trying to explain what humanized mice are then. So when we talk about CD34 humanized mice, don't worry, we're not trying to make little human beings out of mice. We actually talk about mice that we equip with a human immune system. And we do this by taking mice that don't have much of an immune system of their own, and we engraft human CD34 positive hematopoietic stem cells into these mice. So these stem cells eventually will develop in the mouse into several human hematopoietic lineages. And you can imagine that these mice are really cool tools for things that you can't do with wild-type mice. For example, you can take these humanized mice and infect them with human-specific pathogens like HIV. Or these mice have also been very useful tools now to bring cancer immunotherapeutic drugs into the clinic, because you can actually use them for drugs which don't cross-react with mice and are only human-specific. So, of course, now, if you want to put human cells into a mouse, you need to make sure to use mice that don't have much of an immune system of their own. So this is why we use these mice that we call not-skid gamma or NSG mice. And these mice have been engineered to not have any T or B or NK cells of their own. And they have also major parts of their or other parts of their immunity reduced or non-functional. But one question that we get quite frequently is, although these mice are supposed to be totally immunodeficient, there's still maybe some remaining murine immunity back in these mice. And maybe, Dolores, maybe you can take it from here and explain a little bit about how these NSG mice actually work.
Yes, absolutely, absolutely. So NSG comes from NOD, which is the NOD background, the SCID mutation, and the gamma receptor, IL-2 receptor gamma knockout. And combined, these three characteristics of the model make these mice severely immune deficient. And what we see is lack of B cells, T cells, and therefore lack of antibodies. So there's no communication between these two. There's immature dendritic cells. There is no complement system. That's because of the NOD background, and because of the IL-2 receptor gamma knockout, you see no NK cells. Nevertheless, there are still functional granulocytes, and there's still some remaining function from macrophages.
Perfect, thanks. I heard from some people that they worry about the remaining mouse macrophages a little bit. We know that they are deficient, so they don't properly secrete cytokines and chemokines, but they can still eat other cells. So, you know, you have to be a little bit careful that this doesn't confound your results. Nevertheless, you have a mouse now that is very immunodeficient, and you can actually now use this mouse as a perfect host for external tissue and specifically for human hematopoietic stem cells.
Absolutely, absolutely. And this was, groundbreaking, making these types of models that is so severely immune deficient that you can engraft human primary cells, including hematopoietic cells. So, Ralph, a question that came in is what type of human cells engraft and mature when we do CD34 positive human hematopoietic cells? What kinds of human immune cells do we expect to see?
Yeah, so that's actually a great question. And if you take the basic NSG mice and you put these hematopoietic stem cells in, you'll see the human immune cells, different populations, come up in different waves over a period of maybe 3 to 4 months until you have a full-blown immune system. So these mice traditionally have been used for mainly T-cell related studies, because we know that you get good numbers of CD3, CD4, CD8 T cells in these mice, which are also very functional. It turns out that these mice actually have very large numbers of CD19 positive human B cells, although we know that the B cells are somewhat immature and you can't really efficiently immunize these mice, and they don't really make a lot of IgGs, even from the human B cells. There are also some myeloid cells in this base NSG model when you humanize it, but not very many. And what traditionally has always been a little bit of an issue were NK cells. So now this lack of proper development or proper maturity of some of these hematopoietic lineages mainly has to do with the fact that the murine cytokines don't really crosstalk very, very well with their cognate receptors on the developing human immune cells. So, and as you know very well, I mean, certain hematopoietic lineages like myeloid cells or also NK cells, they need stimulation to mature and be maintained in the circulation from cytokines. So to overcome this, this challenge, I would say, the Jackson Laboratory and also other labs over the years have started to make versions of these NSG mice or other immunodeficient mice which transgenically express human cytokines. So that has overcome some of these issues. And I think the slide that Dolores just put up is an example from one of these variants, transgenic variants of the NSG mouse, which we call NSG SGM3. So this is a mouse that has the 3 human cytokines. So it expresses IL-3, GM-CSF, and KIT ligand, and originally was made as a better host for human AML, so myeloid leukemias, so myeloid cancers. But we know that when we engraft this model just with a CD34 hematopoietic stem cells, we get push of certain hematopoietic lineages that we usually don't get in the plain NSG. And maybe Dolores, you can add a few more details to this.
Yeah, absolutely. So what we see when we use the NSG-SGM3 as a host for humanization, specifically with CD34 human cells, is that not only you have B cell reconstitution, improved B cell reconstitution, you have a lot more T cells in the system, including Tregs, which for a lot of people, those are a target for their therapeutics. But the strain itself was specifically made to improve the myeloid branch of the immune system. So you see a lot more myeloid progenitors, you see a lot more monocytes, macrophages, as well as dendritic cells.
So where are the NK cells?
That's a good thing that you noted that. I mean, you can measure NK cells, but the number of cells is almost minimal. Same thing happens with the humanized NSG mice. And for that, we specifically developed another host that's called humanized NSG IL-15, which is a transgenic strain that is expressing the cytokine IL-15, which is necessary for the maturation of NK cells. So that particular host that we have validated recently has accelerated development of CD45 cells in blood compared to humanized NSG. And it does develop very well humanized T cells and myeloid cells. But of course, now the whole purpose of doing this is we validate that it has a significant human NK cell development in blood, and it also expresses high levels of granzyme B, which is the active enzyme that is able to kill specific targets, including human tumors.
Great. So, now that we have all these different variants, I think it's become clear for us, certainly, that there's no strain yet that really solves all the problems and has all the human hematopoietic lineages available. I think what we've also learned, we and others who've tried to make the kind of perfect host NSG strain, is the more a mouse is humanized, the less likely, unfortunately, it is to live, because eventually this great functional human immune system will start attacking the mouse host. So I think and although, we, the Jackson Labs and other labs in the world are trying to solve this conundrum, but I think we're not there yet. And at least for hematopoietic lineages, it looks like you need to choose the proper host strain according to your scientific question and the effector cells that you need. So, it's a tricky question. And Dolores, are you aware of any other challenges of that system?
That we have at this moment? Well, the other limitations that that these particular models have is the antigen-specific responses, which these models are not very robust to show that. If that's what you're interested in looking at, what people call the professional antigens specific responses, where B cells and T cells crosstalk. These particular hosts are not the best for that. And one way to improve that is to work with, to make HLA transgenic versions of NSG combined with finding CD34 human donors that match those HLAs. And so this would be a way to get around that and to improve the crosstalk and look for antigen-specific responses. But,
yeah, of course, because I think the T cells, the human T cells, when they mature from the stem cells, they only see mouse MHCs, right? When they develop in the mouse thymus, and they're not being educated properly on the human HLAs.
That's correct. That's correct. And at this time, it is challenging to make a transgenic or different transgenic versions to match the different potential human donors that there are. So there's a huge variability in HLA between donors, as you know. But we have researchers like Professor Lenny Schultz at the Jackson Laboratory that are actively working on this manner. He's been a pioneer developing models for humanization, and so they are actively working with collaborators to improve more and more these types of hosts to make a more human-like model of engraftment.
I see we're almost out of time, but there was one question that came in from the audience. So the question is the immune system of all these different human donors eventually going to be the same in these mice?
That's an excellent question. Most people, especially new to immunology, have the perception that once you humanize the mice, the mice are all going to be the same. The human system is all going to develop the same. And the reality is that That's not the case even within humans. There is a lot of human donor variability that's observed in the clinic, and that's perhaps why some patients respond to immunotherapies and others do not. There's different explanations for that. And what we keep in mind, and when we do efficacy studies using humanized mice here at JAX, what we try to do is to use several different donors, at least 2 to 4 different donors, to account for that variability.
So that's very much like what happens in the human population, because your immune system will be different from mine, right? And I may react totally different to immunotherapy than you do. So I think that's actually a benefit. Well, maybe it's a double-edged sword. It's a benefit because you can model what's happening in the human population, but then you have to be careful in planning your studies accordingly. So not all these mice are the same like inbred mice. So they're really diverse, right?
Exactly. Yeah. So I think that's all the time we have for this week. Our next MiceTech talk, it's called Let's Talk Humanized Mice Part 2. Let me just share quickly my screen so I can show you how to get there. For next week, you can find us. You can follow the Jackson Laboratory on LinkedIn, and you will get a notification when we go live, or you can also attend it live through the Jackson Laboratory's YouTube channel, which is where we post all of our old episodes in a playlist. If you're interested in browsing previous episodes, that's one place you can go. So this is Dolores saying that we miss you, and we look forward to seeing you in our next episode. And stay healthy, stay safe, and stay excited about research. And Ralph, thank you again for participating in our MiceTech talk.
You're very welcome. Thank you, Dolores.
Have a good rest of your day.
Thanks.